2.6. Combining like terms. This is about taking the next step with expressions. Up until now, we've talked about algebraic expressions, right? They are sequences of terms, 4x, 7, 2x squared, 3y, that are connected by operations, plus, minus, addition, subtraction, division, multiplication. Now we're going to start to simplify these expressions because they can get to be pretty long. And the way we're going to do it is by combining like terms. Now, first of all, what's a term? A term, let's take this first one. 2x plus 4y. In this expression, what is a term? A term is any grouping of constant or variable that is separated by an operation. So in this example, the plus sign is our operation. And until you see another operation, that's all going to be one term. So 4y is a term. 2x is a term. It's a grouping of numbers and variables, coefficients and variables, or it could be constants. If we were to add 7 here, for example, that would also be a term because it's separated by some type of operation. So each of these are terms in an algebraic expression. Okay, and we're going to use these boxes to figure out how to solve them a little bit better. The next thing, we know what terms are. The next vocabulary word would be like terms. Up here we had 2x, 4y, 7. Each of these is a term, but none of them are like terms. Like terms have the same variable to the same power. Like terms are terms with the same variable to the same power. Write that down because we're going to turn the page and move on. Same variable to the same power. So, for example, first one a little farther down says 5x plus 8x. Let's look at these. What are our variables each time? Our x, and there's no exponent here, which means they're both x to the first power, just one x, right? X times 1, x by itself. So therefore, these terms are like terms. And in an algebraic expression, because these are like terms, we can add these together. And it's as simple as this. 5x and 8x, they're like terms. If I have 5x's over here and 8x's over here, that's a total of x, 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 plus x, 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 x. 5x's plus 8x's. If I add all these x's together, I get a total of 13x's. What did we really do? We had 5x and 8x. All we did was add 5 plus 8 and put it back in front of that x variable. So it's as simple as that. When terms are like terms, you can just add their coefficients together and get your answer. Let's look at a couple more examples. The next one talks about 4y minus y. We said that when a variable is by itself, it's the same thing as 1 times that variable. So if I have 4y minus 1y, this is the same thing. any variable times 1 is the same variable. 4y minus y equals 4y minus 1y. So really, like terms, right? Variables the same to the same power. I can do 4 minus 1, which will give me 3y. So we've just simplified this expression from 4y minus y down to 3y. Pretty simple. A couple more examples of how this would work in a bigger expression. Let's do this one. Negative 6y plus 8 minus 2y minus 4. Right off the bat, what do we see? Alright, I see 6y, y to the first power, and I see 2y here. These are the same variable to the same power, y to the first power in both. So, let me go ahead and set these apart so that I know. This is a negative 6y. I'm going to draw a box around this. Negative 6y. And then here we're taking away another 2y. So I'm going to draw a box around this, the fact that we're subtracting 2y here. And then, what else do we have? We have a constant. We're adding 8 here, plus 8. And we're subtracting 4 here, minus 4. So I've boxed my y's, and I have boxed my 8 and 4 in a different color. And you may actually want to draw a circle around these. Maybe it's better to remember a circle. If you're just using pencil, it might be easier if you box one and circle another. Make sure you're consistent with it. When we bring this down, we can change how these look. Let's put these two together. So we can change it to negative 6y minus 2y. When we're adding and subtracting, we can mix up the numbers, do them in any order. It's still going to end up getting the same answer. So we're going to change it to negative 6y minus 2y, and then plus 8, and then minus 4. Again, I've just brought these straight down, subtracting 4, minus 2y, minus 6y. So now that they're next to each other, they're a little bit easier to solve. What do we get? If we start with negative 6y, and we take away another 2y, think about it on the number line, negative 6 minus another 2 would end up at negative 8y. And then we're going to add 8 and then subtract 4. Plus 8 minus 4. If we add 8 but then take away 4, really that's going to bring us back down to 4. So we could write plus 8 minus 4, or we could just write plus 4. If we add 8 and then take away 4, really we're only adding 4, right? So we've just simplified this expression. It would be 8y, negative 8y plus 4. One last example. Let's do number 13. We have 5x squared plus 4x minus 3x squared plus 3x plus 6. Good. What do we have? I'm going to look for my biggest one first. Looks like these are x squareds. Two of them have exponents here, so I'm going to box these x squareds first. We're positive 5x squared, and then we're taking away a 3x squared. And then I'm going to do my x's next. Here's the same variable to the same power, 3x and 4x. I'm going to circle this. Those are the same. And then finally, I'm adding 6 here. That's my only constant. I'll put a triangle around that so it looks a little bit different. Alright, I got 5x squared. I got negative 3x squared. Let's bring these down. So I have a positive 5x squared minus 3x squared. And then we're adding 4x and we're adding 3x. And then finally we're adding 6. Next step, 5x squared minus 3x squared, just 5 minus 3. That would give me 2x squared. Next thing I'm doing is adding 4x and then adding another 3x. So plus 4 and then plus 3. That'd be a total of plus 7x. Last thing is we're adding that 6. No other like terms for the 6. So there we've just simplified this expression. 2x squared plus 7x plus 6. That's how you combine like terms.